Friends, let us take the first numerical of power. This is the first numerical. Army truck of mass 5 tons has tractive resistance of 150 newtons per ton. Find the power required to propel the truck at a uniform speed of 36 km per hour. And in all the three cases, up an incline of 1 in 100, on a level track, and down an incline of 1 in 100. Now let us see what is given to us. It is given mass of the truck is given. Then next is tractive resistance is given 150 newtons per ton. That's all, and the speed is given. Now first let us see what is given. Mass of the truck M, which is equal to 5 tons, so it is equal to 500 kgs. Tractive resistance is 150 newtons per ton. That means when the mass is 1 ton, the tractive resistance is 150 newtons. Now what is the mass? Mass is 5 tons. So the total tractive resistance will be equal to 150 into 5, that is equal to 750 newtons. For 1 ton it is 150 newtons, so 5 tons it will be 150 into 5, that is equal to 750 newtons. Speed is given as 36 km per hour, so this will be equal to 10 meter per second. Slope is given of 1 in 100, so sin alpha is equal to 1 by 100, which is equal to 0.01 is the value of sin alpha. Now we'll take the first case. Power required to propel the truck up the incline. Now the train is moving up the incline. So when the train is moving up the incline, let us see what are the forces that we require. When the train is moving up the incline, it is tractive resistance plus force required for acceleration plus air resistance plus resistance due to inclination. Now here force required for acceleration is not mentioned and air resistance is also not mentioned. So these two parameters will not be there. So total resisting force will be equal to tractive resistance plus resistance due to inclination. Only two things. So let us calculate first resistance due to inclination. Resistance due to inclination is given as mg sin alpha. So mass is 5 tons. So it is 500 kg multiplied by 9.81 multiplied by sin alpha is nothing but equal to 0.01. So that gives the value of Ri, which is equal to 490 newtons. Now total resisting force will be equal to what? Tractive resistance plus resistance due to inclination. Tractive resistance we have already calculated as 750 plus this 490, so that will be 124 is the total resisting force. So power will be equal to total resisting force multiplied by velocity. Total resisting force is 1240 multiplied by 10, and that will give you the power required in terms of joule per second, and joule per second is nothing but equal to watts. So you can also write this as 12.4 kilowatt. So we have done the conversion. 12,400 Newton meter per second is 12.4 kilonewton meter per second. So it is 12.4 kilojoule per second, and 12.4 it will be kilowatt. Joule per second is nothing but equal to watt, so k kilo as it is, joule per second is replaced by watt. So this is how we have found out the power required for a truck when it is moving up the incline. The second case, when the power required to propel the truck on a level track. Now here if we see the formula again, on a level track it is tractive resistance plus force required for acceleration, air resistance. These two are again not given. That means total resisting force is nothing but equal to tractive resistance. So here what is the tractive resistance? Total resisting force is nothing but equal to tractive resistance, which we have already calculated here, which is equal to 750. So the total resisting force is nothing but equal to 750 newtons. Now we will calculate the power. Power is equal to total resisting force multiplied by velocity. Total resisting force is 750 multiplied by 10 is the velocity, and from that we get power equal to 7.5 kilowatt. Now the third case, power required to propel the truck down the incline. Now when the third case is what? Down the incline. So in the down the incline, if we calculate net resisting force, which is equal to TR minus RI. These FA and AR is not given, so it is TR minus RI. So since the truck is propelled down the incline, therefore it has to overcome tractive resistance minus gravitational pull, that is nothing but resistance due to inclination. So here net resisting force is equal to tractive resistance minus resistance due to inclination. It is equal to 750 minus 490. So this gives you 260 is the net resisting force. So here power will be equal to total resisting force multiplied by velocity. 260 into 10, that will give you 2.6 kilowatt. I hope this is clear. This is the first problem. Now we'll take the next question. of the same type. Next question. A train of mass 150 tons moves on a level track with a speed of 20 meters per second. The tractive resistance is given. Determine the power of the engine to maintain the speed. Also determine the power of the engine when the train is to move with an acceleration of 0.3 meter per second square on a level track. So here the case is only of a level track, and here acceleration is also given. So that means we have to consider force required for acceleration. Nothing is mentioned about air resistance, so we will not consider that. So the first part, mass of the train is 150 tons, speed is 20 meter per second, tractive resistance is 100 newtons per ton. When the mass is 1 ton, the tractive resistance is 100. So what will be the total tractive resistance now? 150 into 100, so that will be equal to 15 into 10 raised to power 3 newtons. That is the total tractive resistance. So first is we calculate power of the engine. So we have to first calculate, first was only to calculate the power of the engine to maintain the speed. What is the speed now? 20 meter per second. So at this speed we have to calculate the power of the engine. So here above this only tractive resistance is mentioned. So we are going to calculate the power as work done upon time, which is equal to total resisting force multiplied by velocity. So here total resisting force is nothing but equal to tractive resistance, which is equal to 15 into 10 raised to power 3. So power is equal to 15 into 20. 20 is the speed in meter per second. So this will give you 300 kilonewton meter per second. So if we multiply this by 10 raised to power 3, so this will be newtons, which is already 10 kilonewtons. Okay, so this is nothing but equal to 300 into 10 raised to power 3 newton meter per second. 300 10 raised to power 3 newton meter per second. So it comes out to 300 kilonewton meter per second, or 300 kilowatt, or 300 kilojoules per second. Now the next case. Next is power of the engine when the train is to move with an acceleration. So in the second part we have to consider the force required for acceleration also. Now how do we calculate the force required to accelerate the engine? It is simply equal to Fa is equal to m into A. Now here what is the mass? Mass is equal to, mass was how much? 150 tons. So it is 150 into 10 raised to power 3 in terms of kgs, multiplied by 0.3 is the acceleration. So this comes out to force required for acceleration is nothing but to force required for acceleration is nothing but equal to 45 kilonewtons. Next is total resisting force. So total resisting force will be equal to what? Tractive resistance plus force required for acceleration. Tractive resistance is 15 kilonewton multiplied by 45 kilonewtons. So it comes out to 60 kilonewtons. So from this we calculate the power equal to total resisting force multiplied by velocity. Sorry, it is written as distance. This should be velocity. Total resisting force multiplied by velocity. So total resisting force we have found it as 16 multiplied by velocity is 20. So this gives you power of 1200 kilonewton meter per second when force required for acceleration is also considered. Now next numericals on the same lines. A tram car weighs 120 kilonewton, the tractive resistance being 5 newton per kilonewton. What power will be required to propel the car at a uniform speed of 20 km per hour and on all the three cases on a level track, up an incline and down an incline, and efficiency of the motor is given as 80%. So here efficiency plays a major factor. So from the efficiency we have to calculate the actual power now. Now here see what data is given. Weight is given, weight of the train is given, so we can convert that in terms of mass. Tractive resistance is given, that also we can find out, and test nothing is given. So we'll take one by one. First, total tractive resistance is equal to 5 multiplied by 120. 5 is when it is 1 kilonewton, it is 5 newtons. Now it is weight is what? 120 kilonewtons. So for 120 it will become 5 into 120. So we get total tractive resistance which is equal to 600 newtons. So weight of the tram car is 120 kilonewtons. So it is 120 10 raised to power 3 newtons. Speed is 20 km per hour, so it is 5.556 meter per second. Slope is sin alpha is equal to 1 by 300, so it comes out to 0.003. Now we'll take the first case on a level track. So on a level track, only tractive resistance is given, so the total resisting force will be equal to tractive resistance. This is equal to 600 newtons. Power is equal to total tractive resistance multiplied by velocity. So from this we get the power as 3.336 kilowatt. Now we have got this as power output. Now we have to find out the actual power. Now here we have to use the formula efficiency. Efficiency is equal to power output upon power input into 100. Now we are supposed to find out this power input. Power output is what we have found out. Now we'll find out the power input by using this. 80 is the efficiency of the motor. This is the power that we have found out multiplied by 100 upon actual power. So actual power will be equal to 4.167 kilowatt. Whereas we have got the power output as how much? 3.336 kilowatt. So this is the actual power that is required. Second is power required up an incline of 1 in 300. Now the train is moving. It is a train or it is a train. The train is moving up an